Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. And recently I was looking at the transcripts from like when I say, and the voice recognition usually says DataTalks.Club. So maybe I should work on my pronunciation. DataTalks.Club, which is a community of people who love data. So we have weekly events, and this is one of our events. So if you want to find out more about the events we have, there is a link in the description. Go check it out. Then do not forget to subscribe to our YouTube channel. This way you'll stay up to date with all our streams like the one we have today. And last but not least, we have an amazing Slack community where you can hang out with other data enthusiasts. So join it too. And during today's presentation, you can ask any question you want. There is a pinned link in the live chat. Go there, ask your questions, and we will be covering these questions after the presentation, right? Or during the presentation is also good.
During the presentation is also good. Yeah.
Okay, then like if it's on topic to what we're talking about right now at the moment, then I can ask the question too. And that's the intro slides, and now the floor is yours.
Okay. Is it visible? Can you see the
It is
topic?
visible. I can see black letters on white background.
Okay. So let me get started. I'm going to talk about elevating RAG systems. And I decided to do this talk was because everyone keeps talking about RAG systems being simple. And honestly, they're like the most useful use case of using LLMs, but they're not really simple when you take them into production. About me, my name is Apurva Misra. I'm a machine learning engineer and also an AI consultant. I actually build solutions for like startups that reach out to me. And I'm a public speaker. I started with my speaking journey when ChatGPT came out and became really popular, and everyone was like freaking about losing their job. And I thought it was really important, like even like non-technical people understand how AI really works. Because I am imagining a future where AI would be used everywhere around us. Okay, so starting with RAG, what is RAG? It is a way to incorporate external data with LLMs. It is to retrieve, it has retrieval component, which is retrieve relevant information from external sources based on a user's query, and then use the retrieved information as context for generating a response. So, and why do we use RAG? Is because it is, you have these big LLMs and they're trained on all the data out there on the internet. But it's very expensive to do the training. So they don't have up-to-date information. So for example, if we go and ask any of these models, who is the president of the United States, they might not know it's Donald Trump because they would have to be trained after the elections happened. Or they're using RAG in the background, like pulling the information from somewhere. The other thing is, for example, you have your air fryer company. You might have a lot of proprietary knowledge inside the company, how you refer to like your air fryer models, what is the safety score like. So all of this proprietary knowledge, if you want a model to be able to answer that, or a bot that you build, a system, a chat bot, you would want to give it your proprietary knowledge because obviously it did not have access to it because it's trained on all the public data out there on the internet, but not really your proprietary data, right? It's not public. Then the flexibility and improvements, because RAG, I personally think RAG is more modular. It's not like one big black box model that you cannot improve on. It has like the retrieval pipeline, ingestion pipeline, the generation pipeline. There are a lot of things you can improve. So it's once you build a system using RAG, it's like easier to improve it and actually measure it. So I think these are like the advantages of using RAG compared to like just using like an LLM to answer your questions, because it would go stale after a while. Okay, so this is what everyone generally sees when they look at a RAG diagram. So you have a user on the left side. There is a query coming in, but before that, you have like the ingestion pipeline, the orange arrows that you're seeing. So you have your data sources. It could be like your Confluence documentation. It could be your Slack. It could be YouTube video transcripts, and then you're pre-processing them, like you're chunking them, pre-processing them, and then you're using any of the embedding models and going and storing the embeddings in a vector DB. Then when a user asks a question, it comes to the embedding model. And again, there's an embedding generated, and we find like the top 5, top 10 um, embeddings which are similar to this query, and pull those documents and put them in the generative model along with the query. And then we give the response back to the user. So to the generative model, what you then is the query that the user asks, and also the top 5 documents that might be relevant in answering the question. And the generative model uses that to answer the question. So that is basically a way to add more context and give it to the generative model to answer a query. So the ingestion pipeline, the orange arrows that I was showing, that involves chunking. Chunking is like breaking down your text into pieces. So you wouldn't want to give like the whole PDF document if it's too huge, because these embedding models also have a context limit, right? So you would want to like break it, and you would want to break it such that context doesn't even go missing within a chunk. So you would want to overlap those chunks. Then there is a pre-processing piece. These LLMs do pre-processing in these LLMs process documents different from how users process documents. For example, this is a screenshot from an article by Jeremy Harwood. And what he was talking about was like every website should have LLMs.txt file in there. Because, for example, if you look at the documentation of LangChain, you have like screenshots of like how to go about using LangChain. They would put video as well, and then they would like explain points and stuff. But for LLMs, they don't really care. You can give them like a blob of text, and they can process that, and they can answer questions from that. So like you have to think about pre-processing differently for LLMs. It's just different from how humans process documentation. Then the third point is like saving the metadata. For example, you have documents about your air fryers. You would want to make sure you have the author's name saved. You have the date when the document was created. When was it last edited? For example, if you have YouTube videos, like the link to the YouTube videos, all of that is important because that can help you cite add citations to the answer as well. So this is an example answer from Perplexity, and you see like there is like citations here, 1 and 2, and it's like referring these documents. So like in the database, you have the embedding saved, then you have the actual text, and then you have like the information, like which link, what date, which is the source, Wikipedia, NBC News. This is what it would look like. Okay, so I have removed the ingestion pipeline in this diagram. What you see is just like the query coming in, you have the embedding model, the vector DB, and then the query is going along with the context which was found to the generative model, and the response is going back. And we're going to build on this diagram. Okay, so since we're talking about air fryer company, imagine if someone asks, find me the latest hazard testing report for air fryer 101. So what does the word latest mean in context of your company? For example, this air fryer company, it generates a report every week. So if someone says, find me the latest hazard testing report for air fryer 101, it might mean last week's report. While in another company, it happens every month. So it might mean last month. So it's like contextual or personalized to your use case. So how we would process this query would be different, and a vanilla RAG system would not apply here. Another query is what was the safety score in there. So since this is just a follow up from the previous query, we would have to keep in mind what there means, right? So we have to keep the historical conversation in mind as well when we are answering that question. So this is where the memory piece comes in. Then for a query like this, which air fryer, 101 or 102, had a better safety score? This is I would call this a compound query. You can break this down into simpler queries like what is the safety score of air fryer 101, and then what is the safety score of air fryer 102, and do a comparison there. So this, again, like you cannot use a vanilla RAG system here. You would want to like process this query before you go and try to find whatever is there in the vector DB similar to these queries. And then for a query like this, when was the last time Jeremy's restaurant bought air fryers from us? Here, we don't know what Jeremy's restaurant's name is. The bot wouldn't know this. And the only way we can get this information is maybe if we connect it to a CRM, and it can pull out what Jeremy's restaurant's name is and like replace that in there, and then go look it up in the database. So again, like based on your specific use case in your company, you would have to look at the queries and what kind of questions people are asking, and then figure out what data sources you need. And this is where like the vanilla RAG system would not apply. And you would need something called query transformation. So query transformation could involve a lot of things, like you're breaking down a compound query into multiple queries. You're doing query rewriting, in which, for example, when they're referring back to the safety report, what was in there, like it would write that as what was in the safety report, rewrite it using the historical context into account, so that the bot understands it better. So, and the other thing is like the metadata piece. It's able to use the data which is in the CRM, and find the metadata and use that in the citations as well. The other thing is like adding filters. For example, someone says, or the query that we referred to earlier, like what was the safety score in the latest report? We can rewrite it and use the dates. So when we rewrite it as what was the safety score in last week's report, we can switch them with the dates of last week, and then use the metadata to filter that out, and use that to answer the question, if that makes sense. Like rewrite the query such that our metadata is applicable, and we are adding filters. Okay, so this is what our RAG system would look like. You have the query coming in, and based on like how the query, sometimes there would not be any rewriting happening, but sometimes you want to take the historical conversation into account, rewrite it. Sometimes you want to take the company use case into account, like the latest report, and we know that in the database we have date filters. So like add that. And then I've switched the vector DB from databases because you might be pulling it from a CRM. You might be pulling like more information from a CRM. You might be pulling information from SQL DB, or you might be pulling stuff from like vector DB. And then there is like the context construction part. Like you're adding all of that into the context, and then you have the generative model creating a response for the user. Okay, so ingestion pipeline also involves embedding model and the fine-tuning part. Honestly, you can go use any of the embedding models out there, but there is a ranking present on Hugging Face. This is, I think, a week or so old, this ranking, so it might have changed. But they use a bunch of different measures. So you can see like clustering, pair classification. STS, I think, is the most relevant because it uses cosine similarity right here. But you can, even if you use this, use the best ranked model from here, it might not work in your use case because in your use case, you might have something like this. There are two users. One is saying, I want to confirm my subscription immediately. The other one is saying, I want to cancel my subscription immediately. For embedding models, these might be like close to each other, like next to each other, but in your use case, these might just be like extremely different emotions, and you want them very far apart in the embedding model. So this is where like you might want to test these embedding models for your use case and see how the embeddings turn out to be and choose the right one, or you might want to fine tune it so that it like puts these two like far apart. So this is where like the embedding model and the fine tuning comes in. Then you have the retrieval pipeline. The retrieval pipeline in a vanilla RAG system is basically you have the query coming in, it's going through the embedding model, you're trying to find the top K matching documents. But for example, if you have a query like this, what are the treatment options for, I don't even know how to pronounce this, Creutzfeldt-Jakob disease? It's a neurological disorder. It's pretty close to Parkinson's and Alzheimer's. What a vector DB matching or like cosine similarity would do is get you Alzheimer's as well as Parkinson's documentation as well, because they're very similar diseases. In the embedding model, they are tagged very close to each other. But you would want only the documentation relevant to this disease. That's where like the keyword search comes in, and the hybrid search part. You would want to have the search piece, the retrieval pipeline. You would want it to have not just vector embedding matching. You want it to have keyword matching as well. So you want embedding matching plus keyword matching. And then you take out those documentations, top K from both ends, and then you can like re-rank them and use them. I'm coming to re-ranking. So why do we need re-ranking? Re-ranking is needed because if you think about it, you give a lot of text to an embedding model and it generates like a small vector, 1,000 something vector for you. It's like you can have 512 as well. Like it generates a vector of a certain size for you, which is like way smaller than the amount of text you've given in. So obviously there's like compression happening, so you're losing information. So what re-ranking lets you do is make make sure like if you're pulling like top 10, like re-rank them so that the relevant ones are on the top, relevant documents are on the top. And why this is necessary is our current like RAG system uses it's a by encoder. So what it's doing is you have the documents. This is the ingestion pipeline. You have like a bunch of documents. You're using an embedding model, generating the embeddings, and then saving it into a vector DB. Okay, and then you have your query coming in from the user. This is happening at a certain time. Like you have like a bunch of documents. You might be doing it every night when new documents come in. And then you have a query. The user during the day asks a query. You're using that same embedding model and then using that embedding to find the matching top 10 documents. But what is happening here is it's the embeddings that are generated for the documents are not taking the query into account. It's just like independent of the query. It doesn't know anything about the query. So these are like two separate pipelines. And that's why it's called bioencoder. So here that is exactly why a re-ranker would come handy here, is it's basically you're using a less expensive model and finding like the top 10 embeddings which are closest to the query embedding and using a more expensive model to re-rank them while taking the query into account, if that makes sense. So you have your ingestion pipeline and you're getting the documents stored in the vector DB with their embeddings. And then you have the query coming in, you're generating an embedding for that and doing the cosine similarity. But because you cannot generate those embeddings for the document taking the query into account, what you can do that you can still do that but live, but you would want to like reduce the number of documents you're doing it for. So you're using a less expensive model, getting like the top K, and then within those top K you're using a re-rank to make your matching better, just like using the top 5 out of that if you have pulled top 10. And also, like I would say, re-ranking. For example, there is Cohere re-ranker, which is really popular, and they give you a re-ranking score there, which is also really relevant. I'll talk about that later. Okay, so the next thing is multimodality. So there are two ways you can go about it. I don't want to dive deeper into it, but basically, like with multimodality, what I mean is you can obviously work with something other than text. You can have images, you can have audio. One way is you are using a model which is generating the embeddings for the text, image, audio, all in the same semantic space. The first one. The other one is you use like a vision language model to like generate a caption for the image, you can have the transcript for the audio, and then like it's just text, and you're again working in like the textual semantic space. You can go either way in your use case. Okay, the next thing is model gateway. Why model gateway is important is if you think about your code base, you might have like a lot of OpenAI calls that you're doing in a bunch of places. And if OpenAI changes its API, you would have to go change your code in so many places. So instead of like having it like spread throughout the code base, rather have a common interface where like a request comes in, a request like looking like this comes in. And you can like, based on the request, you can call the relevant model. What this lets you do is this lets you have access to like multiple models as well. You can have it all in one place. And why this is important is sometimes these companies also have rate limiting. So sometimes and sometimes the response is pretty slow. Sometimes if one of the APIs is slow and not responding, you can call another API or you can do parallel calls to multiple APIs, and whichever responds the first, you can send the response back. The other thing it lets you do is do access control. So maybe you have an intern in your company and you don't want to give the intern like access to a more expensive model. Or like see how many requests are getting done by which user. So there's just one interface to the models. You can again rate limit the users within your company as well. And what I mentioned earlier, like retries, it lets you like call other models. You can decide which one to call if the other one is slow or if it's limiting you. And it's one interface where you can like monitor your LLM calls. Okay. The next
have a
thing.
question. So you said it's okay to interrupt you. Do you know any implementations for this model gateway? Like, of course, we can implement it ourselves, but maybe there are existing implementations. So I was thinking of LangChain, but LangChain is more like a library. And what I understood for model gateway, it's like a separate service that you use, that you make calls to, which in turn makes calls to like external APIs, right? So this is like a standalone web service.
So I have implemented it myself mostly. So it can be as simple as like you define like different functions, and based
Mhm.
on the call, you can like know you can figure out like which one to call. So you have the
So
model type,
this
like
would be
oh, you have to
like a
go to OpenAI.
simple Python
Yeah,
module, right?
yeah,
Uh-huh.
yes, yes. But I'm pretty sure there are a lot of solutions for this with better monitoring and stuff. There must be a lot of solutions, but
So I
I have
thought
implemented it
when
myself.
it comes to rate limiting, monitoring, I don't know, access control, then it's not a simple library. It's more like a separate service.
Yeah, yeah. There must be solutions. Let me find them and maybe I can put them in the comments.
Yeah. Okay. Thank you. I think there is also a comment that we implemented our own. I don't know if it's related to our discussion or something else, but yeah, it looks like there are at least two implementations, yours and okay, yeah. So thanks.
This is like how well how important and how what all you can implement. It's not necessary you need all of these features. I would say monitoring is really important, but
Yeah.
and retries. But I
Uh-huh.
don't know if you need like access control within your company. So it
Yeah.
depends on like how complex you want to make it, right? Okay. Yeah, just stop me, Alexi, like if you think there are any questions. Um, okay, so the next thing is query routing. Query routing is important because it can help you save costs and make your implementation better. For example, you have the queries on the left side. So you're a department store, and someone comes and asks, "How do I connect my Bluetooth headphones on to my smartphone?" Then someone comes and asks, what is your return policy for online clothing purchases? These might just be like two different vector DBs. You might have a vector DB where you store information about your device, technical information, some stuff from the brochure. Then you might have a vector DB where you store policies about your own department. So you would want to route the query such that it's like going the right path to look for stuff in the vector DB. The other thing is the queries could be in different languages. So you might want to route it to different models based on like which model is better at which language. The third kind is like um, travel booking and restaurant reservation. Book me a flight to New York for next Friday. Reserve a table for two at an Italian restaurant tonight. So for the first one, like I would need to look at the calendar of for the person. I would have to go to Expedia and book the flight. So there are like two separate calls that I'm doing. For the next one, I might just have to like look at the calendar and I would have to go to OpenTable. So these are like different tools that I'm calling. So like query routing, it could be a bit complex as well, like based on like different cool tools you're calling, different models you're calling. But it's a way of making sure that you can reduce the cost as well as the right thing is getting used for that query. So you're figuring out what all tools the query needs to answer it, or which tool or which executor is the best for it. For for example, a query could be very simple, and you might just want to call a smaller model, or a query could be very complex. You might want to call Claude 3.5 Sonnet. Um, so you can save costs. You don't want to use a bigger model for a very simple query that could be answered with a smaller model. So this is where like the query routing piece comes in. It's basically like you look at the query first and decide what all it needs for this query to be answered, and just like route it such that it goes the right path.
And the way you do
And
this, you're going to explain right now. Yeah.
yeah, so you can have a classifier. It could be as simple as SVM. And you can go very complex. You can use an LLM for this as well. But I would say it depends on your use case. It's just to figure out like this query, how it could be, which is the right path to choose for the query. And it's also a way to reduce the cost. You wouldn't want to use something very complex to answer a very simple query, and it does cost more to use something more complex. And here I've shown dotted lines because you might do parallel calls as well. For example, you have the calendar tool, you have the Expedia tool, you have the open table tool. You are doing parallel calls to calendar as well as Expedia for one query, and you're doing parallel calls to calendar and open table for the other query. So that's why I put dotted lines. Okay, this is what a RAG system looks like now. You have the query coming in, you have the query rewriting happening, and then I've put databases, you're pulling information from wherever, and then you're doing context construction, and you're doing re-ranking there as well. You want to focus on the top whatever documents which are pulled, and here your generation has been replaced with a model gateway. And here routing is also happening because you might use an LLM for routing, and you have those tool calling happening in here as well. It could be here as well. It could be here as well. But this is where mostly like the routing and the generation happens. This is where the LLM piece is in here. The next piece, which is important, is guardrails. This is a very complex diagram, but what I want you to focus on is this part. You have the LLM right here and this green piece. So why guardrails are important is you don't want anything. For example, you don't want any PII, personally identifiable information, going into these LLMs. These are black boxes, and especially when you're using APIs of third party, you don't want any of your proprietary information going into the LLM. So basically, a guardrail is like a filter between the LLM and anything going in and anything coming out. Because these LLMs can generate like toxic language, or they can talk about the competitor. You don't want any of the responses going directly to the user. You want to use a filter in between. So a guardrail is basically a filter. That's what I want you to remember from this slide. It's just a filter between the LLMs and anything else. Okay, so this is an example conversation. Someone is asking, hi, I'm having trouble logging into my account. The bot is like, I can help you with that. Can you please provide me with a registered phone number? The registered phone number is a PIR. The person gives the phone number, and what happens inside the code is basically the phone number is getting replaced with the word phone number. It's a reversible PII dictionary. So yes, we are using this phone number to find this user in our database, and we found the user, and now we need to respond in natural language to the user right here. What we're going to do is we're going to take the information, give it to the LLM saying this user has been found, but still we're going to use the word phone number instead of the real phone number. And the bot would also respond with this answer: thank you for your patience, I found your account, blah blah, with the word phone number. But since we have the stuff saved in the reversible PII dictionary, we're going to replace the word phone number with the actual phone number. So to the user, it would look like nothing really happened with their phone number. Like they send the phone number and they see a response with their actual phone number getting used. But in the background, when the actual LLM call was made to the LLM to generate the natural language response, we never use the actual phone number. We use the word phone number. And this is possible because we're using a reversible PII dictionary. Basically, what we want is nothing no personally identifiable information is going into the LLM. Instead of that, we are going to replace it with the words. It could be email, it could be name, it could be phone number, address, anything relevant to your industry. So this is what a system looks like. So what I was telling earlier, like this is where the LLM calls happen, right? So you have the query coming in, query rewriting is happening. Databases is where you're pulling information from. It could be a web search, it could be Wikipedia, it could be a CRM. Then you have the context construction happening, and then you have re-ranking within that. And this is where the green boxes are added. You have the input guardrails before anything goes into the LLM, and then you have the output guardrails before the response goes out to the user. You don't want your user to see toxic language. You don't want your user to see you talking about your competitors or you talking anything bad about your own company. LLMs can make a lot of they can hallucinate. So you need to have guardrails for all of that. So the green boxes are the ones which prevent you from all of this. Okay.
I'm just curious, maybe it makes sense to include the guardrails in the gateway. So for the users, they just use the gateway without worrying about all these guardrails, and the guardrails kind of happen inside.
Yeah, you can do that. It's just like I've added it to the diagram such that basically it's like what I want you to remember is like guardrails are basically filters. Anything going into the LLM, anything coming out of the LLM, you need to have filters before.
Yeah, I was just thinking about like practical implementation. Do you know any tools or libraries that help us implement this easier?
So, for example, I was working on PII. I use NLTK, Spacey.
So usual NLP tools.
Yeah, regular expressions, but they do not always work. And that is where like you can use AWS Comprehend as well. Because what happens is you can figure out with regular expressions, you can figure out like typical email address and phone number use cases, but you cannot like think of like every format that the person can ask or say that in. And that's where you need to use like neural networks and figure out based on the context, is that a phone number? Based on the context, is that an email address? And filter that out. So there are a lot of tools. There is guardrails.ai. Like it has a bunch of guardrails that can be used. AWS Comprehend is a good one as well for PII. Yeah.
Okay, because like this is one of those cases where you can't use an LLM to do that. Because in other cases, like I don't know, query rewriting, basically everything we discussed so far, query routing, you can just use an LLM to do this job. But this is one of the cases where like you kind of don't want to send PII to an LLM, so you cannot use an LLM to do guardrail.
Exactly. Yeah, makes sense.
And then you have to use something like Spacey, basically implement this thing yourself, or take a look at, as you said, Guardrails.ai, right?
Yeah.
Where we can take a look at libraries. Would it be okay to maybe have like a local LLM if we just do the inference?
Yeah, for sure. You can have a local LLM to do that as well. Some companies don't even want to use an API. They want to use a local LLM, especially with like Llama 3.3, I think 70 billion. It's amazing. So if you can like host it, you don't even have to worry about like information going in. You're hosting it.
Right? Yeah. Okay. Makes sense.
So
Thank you.
I think I mentioned that in Model Gateway as well. You can have like self-hosted models at the bottom, I think. So you can have OpenAI calls, Google, AWS, and then you can have self-hosted models.
I'm wondering how good the LLMs are in identifying PII. Like if we use Llama to do that before we send it to OpenAI or something.
Pretty sure you can do that. I haven't tried it yet. But like I was saying, like these rule-based systems, they fail most.
Yeah.
Sometimes.
For corner
But with
cases.
PII, you have to be like 100% careful, So it's better to use neural networks there because you want to take the context into account if this is a phone number or an email address. Right. Okay, moving on to the generation piece. So we have covered the ingestion pipeline, we have covered the retrieval piece, and now we are moving on to the generation piece. For the generation piece, on the right side, what you see is this is how your prompt is going to look like, you would have, first of all, you're going to talk about your company. You are a helpful assistant. You are a chatbot for a trucking company. This trucking company has shippers, and then there are brokers in the middle, and then there are carriers, the truck drivers. The truck drivers have DOT numbers. So I'm going into like how many bots that are very relevant to just the trucking company could be used, and you have to explain all these terminologies to the bot, to this model. So this prompt itself can grow a lot. You explaining stuff about your company. This could be the system prompt. Then you would want to add examples in there, for this kind of query, this is what we do, blah, blah. So again, it's going to grow. Then you have the documents that are getting retrieved from like the CRM, from the SQL response, from your vector DB. There are a bunch of documents here. Then you have the historical conversation. The historical conversation, again, depends on your use case. It could grow up to like 70 messages long, So again, getting added into the prompt. Then you have something called a cautionary prompt. The cautionary prompt would be, don't talk about our competitors, talk good about the company. If you see the word phone number, it's an actual phone number. If you see the word email address, it's an actual email address. So this is where you caution the model, the model to like behave a certain way, and that is where the prompt compression parts comes in. If your prompt has grown a lot, it would cost you a lot, and you would want to compress it into something smaller, even, and still gets the job done. You want to reduce the number of tokens. That's what is prompt compression. The other piece is the prompt engineering part. Prompt engineering part is also like what grows your prompt. Like if you're using chain of thought, you are still growing your prompt a lot. But I wanted to talk about prompt engineering. Prompt engineering is really good if to get your model to behave the way you want it to. So look into all the prompt engineering techniques there, and then look into prompt compression. Prompt compression is just about like reducing the cost. Prompt engineering is more about getting it to behave the way you want it to. Okay, so this is what your system looks like now. You have the query rewriting happening, databases where you're pulling the information, context construction, re-ranking, the prompt processing piece, and then you filter it out, making sure like even after the prompt processing, no PII information or any other information that shouldn't go into the model should go into the model. And then before it goes to the user, you're doing, again, some sort of filter. Okay, the failure management piece. The failure management piece, I wanted to make a slide just out of this. Even though I spoke about it in Model Gateway, this system would still not work all the time. These LLMs do not respond. They do not respond 100% of the time. They're slow. So it's very important that you have a way to retry your request. You are doing parallel calls. Or you have a way to transfer it to a human being. So always think that this is not 100% reliable yet, and have a backup plan. And that is all I want to talk about, is failure management, but it's very important to keep this in mind. Okay, the next piece is caching. Caching is you build your system and it would be slow. And that is where the caching part comes in. There are 3 kinds of cache. One is called the prompt cache. Prompt cache is basically what OpenAI gives you. It does it by default now. Basically, like you have the system prompt where you're talking about your trucking company, and it's very long. It would cache it. It wouldn't like process it every single time. And this would like save you like, I don't know, in OpenAI, I think it's 50% of the cost. And it's available in Claude as well. You just have to implement it, the prompt caching part. So that is what I mean by prompt caching. It caches like the repetitive part of the prompt and doesn't process it again and again. The next piece is the exact cache. The exact cache is basically if the query coming in is exactly what we already have saved. We are gonna respond with the answer that is saved. Exact cache could also be present within the processing piece. What I mean by that is, if you have a query like this, explain the impact of inflation on tech startups. Here, there are going to be like 3 steps. First, we're like retrieving the economic data. Then we are analyzing the trends. And then we are generating the explanation. So we can cache any of these pieces, we can cache the result of analyzing the trends, or we can cache the result of the economic data, because we did a web search. The web search also takes time. We cache like the in-between steps. So that is also where you can have exact cache. So if someone asks another query where also we have to retrieve economic data, which is exactly the same as this, we will just use the cached result, or the result of this, or whatever, like if any of the in-between pieces are matching. And there are cases where it wouldn't work. For example, what is the current temperature in Paris? This is time sensitive, and obviously the current temperature keeps changing. It doesn't make sense to cache it. A query like this, show me my recent orders. This is very personalized to me, so it doesn't apply to Alexei. So it doesn't make sense caching something like this. It doesn't apply to another user. What are the latest news headlines? Again, time sensitive. These latest news headlines keep changing. Doesn't make sense caching it. How many users are currently online? It depends on a third-party system. Doesn't make sense caching it. It would keep changing. Summarize this article, and someone uploads an article. Again, it's very personalized to that someone who uploaded an article. It doesn't make sense caching it. It doesn't apply to me as a user. So caching is amazing, but you have to figure out what should you be caching. Does it even make sense to cache this? Is this even relevant to other users? The other kind of cache is the semantic cache. Semantic cache is, again, like the embedding based thing. You have a query like, what are the best laptops for students? And you have a query, can you recommend good student laptops? They're very similar in the embedding space. And if we can figure that out, we can use response for either one of them. So if we have response cache for one of them, we can use it for the other one. For a query like this, articles about AI in healthcare, write-ups on how AI is transforming healthcare. Again, the same thing. If we have response saved for one, we can use it for the other one, because they're very similar in the embedding space. But this is where it's a bit unreliable, because it will completely depend on the embedding model, if it's able to figure out like how close. And then you would have a threshold, like if it's above 0.87, yes, I find them very close to each other, and I'm going to give the same response back. So it's very subjective to you and the embedding model that you're using, and not reliable. For example, what's the capital of USA and what's the largest city in USA? They might be very close in the embedding space, but these two have very different answers. The other is, what's the best restaurant? What's the best restaurant in New York? Again, very similar on the embedding space, very different answers. This would have like context of where the person is anyway. So doesn't make sense. So I haven't used semantic cache yet, but I've read a lot of stuff about it and people using it. But honestly, it completely depends on your use case and the embedding model, how close it is to your needs and what the threshold you're using. But this is what our RAG system looks like. Basically, you have a query coming in. You have cache here. If the query matches or is very close, you give the response back. Then you have the query rewriting happening. There's obviously a cache here, which is like for in-between pieces, in-between steps that I was talking about. You might want to cache those. And then you have the context construction, re-ranking, prompt processing, input guardrails, output guardrails, the model gateway. And then again, this is the dotted line here. You would want to cache the response. And like I was talking about this like before, the exact cache. You might want to use something to figure out. It could be a classifier to figure out which queries does it make sense to cache. Okay. Now we are done with our system. What else? You obviously need to improve on it. You would need to iterate on it. And this is where the observability piece comes in. And that is how you can evaluate the system, right? You would want to observe everything, every single thing. The input query, the output, the rewritten query, the cosine score, the citations, the re-ranker score. This is very good. if you can save the re-ranker score, you can actually figure out if your retrieval, how good is your retrieval part. If the in the top 10, if the re-ranker is like giving them low scores, that means your retrieval part is not that good, so you want to see if the re-ranker score like correlates with the retrieval piece of yours. The context retrieved, user level metadata like organization ID, user role, sign up date, device types, geolocation, language, all of this, because this would help you figure out like the kind of queries users are asking, which kind of users ask which kind of queries. For example, the new users might be asking certain kind of queries. The more experienced users might be asking certain other kind of queries, and you might want to improve your onboarding to cater to the new users. So you can improve your system if you can figure out the kind of queries, which kind of users they're asking. It could also like important to save the device type. It might change if they're using a mobile phone to if they're using a desktop. Performance metrics, very similar to like software engineering, like response time, token uses, API call types. Then you have human feedback. Human feedback is it's pretty slow. It takes time. Not every user would give you feedback, but very important. And be very specific. Don't say how did we do today. Ask like did we answer your question? Because people would say, oh, you did really bad because I didn't like the color theme on your website. But be very specific about what you want to know from the user. It could be like explicit. You're asking it. It could be implicit. For example, how GitHub Copilot works. It gives you a suggestion, and if you keep writing, it would get an implicit feedback that this person didn't like the suggestion. So it could go both ways in your use case. LLMs as a judge, you can use LLMs as a judge to evaluate your system. But please make sure that the LLM that you're using aligns with the domain expert. Like the prompting that you're doing to the bigger, more expensive LLM that you're using as a judge, it aligns to your domain expert. So that's the most important piece there. And all of this is important is because when a new model comes out, which happens so frequently now, you are not sad about it. You're like celebrating it because it's easier for you to like test out, replace it, test it out, and see what the metrics look like, evaluate it. It's easier for you to do that, and you're happy about a new model coming out. Okay, so what I was saying earlier, like all of those metrics and monitoring that you're doing, it helps you find patterns. You have to analyze those. It could be like finding patterns within the queries, like the kind of queries that people are asking. Is the query length changing? So it's very important that you find patterns in the kind of queries people are asking. So it could be, for example, a company I was working for. It's a SaaS company that provides software to staffing agencies. These are the three kind of queries that I've noticed them asking. Like, why is it saying this field is required? When all the information is entered, there would be spelling mistakes in the application builder. So in this, what I realized is I need to take a screenshot because I don't really know what this person is talking about, saying this field is required. I don't have any context. Then the other kind was, how do I create a gift card? This was like a perfect query which could be answered from their documentation. Then the third kind is, hello, all jobs have been assigned in progress for today are not showing up on the shift jobs calendar. Can you explain? This was the query where I should have routed it to a human being as soon as possible because this wasn't solvable by documentation, and this person seemed like frustrated, like something that was supposed to work is not working. So you have to figure out the kind of category, the categories, like clusters of queries that you have, and are you resolving all of them, and or how you can improve to resolve all kinds of categories. The other is like you can categorize the users based on the queries. Like the new users ask this kind of queries, the older users ask the other kind of queries. The other is it helps you do anomaly detection, which is really important. There could be, I have experiences, malicious activity. People coming in and they're figuring out that there are LLMs behind your bot, and they would ask a lot of questions, or they would ask questions that are not even relevant to the system. So it helps you figure out what kind of malicious activity is happening. Because in the cluster, it would be like very far away from the cluster. Okay, this is where I wanted to show you the demo. So this is a smaller piece of the queries, the staffing agency software that I was talking about, but this is what it looks like. So if you let's look at, I'm using Nomic. They have an embedding model, which is really good. And I have plotted them in 2 dimensions. And these are like these colors that you're
Queries?
seeing.
Like all these dots,
Sorry?
are they queries or what? Queries from
Those
the
are the
users?
queries. Those are the
Uh-huh.
queries from the user. So the different colors that you're seeing, those are the clusters. And the query, you can see it right here. So when I move it, you would see the query changing on the left side. So the gray ones, you can see everyone is asking about the email template. Do you see that? Email templates, how to create email template. So it's all about email
We
templates.
see this on the left, right? So there is this prompt.
Yes. The other would be like the yellow ones. How do my candidates log in? Username and password. It's all about like login, first login. So this is also something like logging in. People don't ask like a normal question. They would just write logging in question mark. So and that is why like a RAG system becomes more complex, because what you expect the users to behave, they don't behave that way. They would ask you password question mark, and you would have to figure out what they're trying to ask. So that's where it's important to like analyze what people are asking. Um, okay, there could be cases where you don't have users and you want to evaluate your system. And LLMs would come to your rescue, because LLMs are so good at generation. They generate such good images. This is the vision stuff though. But LLMs are really good at generating. So what you can do is you can take your documentation, give a chunk of it to the LLM, ask it to generate questions that could be asked from that chunk, and generate the answers. Okay. Then what you can do is you can give a query, that one of those queries, to your system and see if it's pulling the relevant chunk. So this is a way for you to assess your retrieval piece. Then you can obviously do the generation piece as well and see if the answer is similar to what you had generated. So this is the way for you to evaluate your system when you don't have users. Okay. I spoke the whole RAG diagram that I showed. Then it would get very complex as you start building, and that is where the orchestrators come in. These are diagrams that I've taken from 2 different ones. The one on the left is LangChain. The one on the right is Haystack. Basically, these are again like RAG systems. You have like a query coming in. You have the retrieval piece happening. You have the prompt builder. The context is getting added, then you have an LLM, and then you have the answer getting generated for the user. So as you keep adding pieces, you would need an orchestrator that would make your life easier and simpler, I would say. And you would be able to visualize your system easily. Okay, so what now? You have your system ready. Are you good? No, you would still have issues. These are like a couple of them that I have experienced. Like you would see that the conversations with your bot could go on for really long, and it becomes really hard for them to answer if the context is really long. That's where you would want to like summarize the earlier piece of the conversation, or you might just want to cut off the earlier piece of the conversation. Depends on your use case. But you're trying to reduce the amount of like stuff going into the LLM. Second thing, bad actors. You would want to like figure out if they are a bad actor as soon as possible. Stop that conversation, because it's costing you. If they're talking to your bot, you are making LLM calls, it's costing you. The third piece is PII. Again, have tried. You have to keep trying, and you have to be 100% sure any of the PII doesn't end up with LLM. None of the PII should end up with LLM. You should be very robust with your PII filtering. The fourth piece, I have seen cases where the user feedback was a thumbs down. I looked at the answer, I looked at the query, I looked at the retrieval document, and I spoke to the domain expert. It was all correct, but still, it was a thumbs down as a feedback. So I think one could be because there's like friction in like typing out your question, um, or maybe the system was slow. There could be a lot of pieces there, like try to figure out why this could be. In my case, I thought audio input could be useful because it reduces the amount of friction. You don't really have to type out a question. You can just like speak to the bot. So figure out how your system is working. Even after you build all of this, like it's again an iterative process. There could be a lot of things you can improve on it. The other is the UX piece. The UX is the most important here because this technology is so new. You want to align it to the user's expectations as much as possible. You have to make sure you set the right expectations because obviously these LLMs have limitations. For example, like ChatGPT, like at the bottom it says ChatGPT can make mistakes. Check important information. Very important. This, for example, Google, it says this response was double checked with Google search. Very important to do that. The other piece would be oh yeah, set the right expectation. The other is like citations, right? This is the one that I have built. Like it's not really a chatbot. It's a Q&A system. You ask a question, it pops up with the answer. Thumbs up, thumbs down, feedback. We spoke about all of this. Citation, get in touch with the human when they click on this. So very important for them to like go to the right person if the bot is not able to answer, like going to a human being. The other is like efficient dismissal, which I think I spoke about before. GitHub Copilot is like perfect for that. Like gives you a suggestion. If you keep typing, it goes away. You don't have to specifically do anything for it to go away. Provide attribution. I showed it to you. Like citations, very important. Is chat even the best interface? I don't think so. You have to figure it out for your use case. Like for the one company that I was working with, we built a Q&A system, not a chatbot. Latency perception. These LLMs are slow. The response takes a bit. So you might want to use streaming when you're showing the output, like the way ChatGPT does, it starts like typing out the answer. We don't wait for like 10 seconds for the answer to get generated and then we show the answer. So that's one way. Feedback, again, this is an example from character.ai. They're like very specific when you go into the feedback piece, like was it too short, boring, not too repetitive? So you can be as detailed asking for feedback. This is a video of me asking a question to the Owen model, which is pretty slow because it thinks. But I'm asking what does happiness mean? But if you see, like it's showing me stuff, it's thinking, it's taking a while, but it's showing me stuff during that time, like breaking the question down, thinking about it, thought for 7 seconds, and then it like starts typing. So there are things you can do in your user interface to make it seem like your system is not slow, or how the perception, or at least the perception of it is not slow. The other is perplexity. I'm asking a question here. What is the meaning of life? Again, like breaking it down into steps, showing me things. I haven't gotten the answer yet, but I see like stuff happening. And then again, it's like, it's still the answer. It's streaming. The answer would come out. And then the other thing which I like about perplexity is after it gives the answer, it tells you like suggested questions you can ask later. So there is a lot of things you can do with the user interface to make your system not seem slow and make it better, because it's a new technology, they make our life easier. It's suggesting me questions that I can ask next. Okay. Finally, like what's the most important is you're building this for a business use case. Is it generating the value that it needs to? Is there ROI on it? Right now, this technology, AI, LLMs, everything is so popular. Everyone wants to use it, but it's very important to like take a step back and figure out, is it really necessary? Is this the only way I can solve it? Because AI was there before LLMs came into the picture, classical machine learning, very reliable. Think about it. Is your solution actually driving the value for the business? And then like work towards it. Okay, recap. Always look at your data. You have built your system, it's out there. Look at your data, all the metrics, the queries, the answers, what's getting retrieved, please look at your data, like set up a timer, do it like every week. See how you can improve on your system. You have to look at your data even before you start building the system, actually, the kind of things which are why you're building the system, find out what your users are looking for. And does your system really align to it and you're solving their problem? What I tried doing today is start simple and grow more complex. But what is more important is you also please start simple, start with like making it work, then think about like making it fast, and then think about like making it cheap. You might not want to do like calls to GPT 4.0 or Sonnet 3.5 all the time. So that's where you would think about like making it cheap. But please, like what's more important is it works, the fourth thing is guardrails are very important, but there is a trade-off there, because as you add more guardrails, your prompt or your response has to like go through them, you're adding more time. So there's a guardrails versus latency trade-off that's happening there. So you have to figure out like what's important in your use case. Yeah, that's it from my end. This is how you can contact me. That's my website. That's my LinkedIn. Are there any questions?
Yeah. So one thing is, I'm just trying to get the terminology right, and I'm wondering like when is it RAG and when it becomes an agent? Because there were some cases where, so for example, when we were talking about query transformation, like in these cases, we would need to connect to CRM and get data from there. Or when we were talking about query routing, there were questions like book a flight, reserve a table, or a question like how many users are currently online. Is this still RAG, or when can we say that, okay, like maybe what I'm trying to ask is when we can call our thing an agent and no longer a RAG, or like is there even a difference between these two?
So you have I would say these are like function calls or tools or skills. These are like skills that you're giving to your system that it can utilize to answer the user's query. Right now, like I don't even see the word agents being used. It's agentic systems mostly. But when you give your system access to skills, it becomes more agentic. But there should be the other piece there is like the moment your system is the one making decisions on what to call or how many calls you have to do, or oh, this is not correct, let's go back and I'm going to make one more call. This is where it like goes into like real agents. It's the autonomy piece is where I would say it goes into the real agents part. Like when it starts making its own decisions, um, that's where it's agentic. Yes, in RAG systems as well, we are giving it access to skills and functions. You can make it more agentic if you let it like reflect. If the user asks a question and it's like, oh, I need more information from the user, I go back and ask a question, oh, tell me more about this, and I get this response from the user, and now I have all what I need to make those function calls to get the answer and then give it to the user. This is like more agentic, it's it's autonomous. Like we are giving more autonomy. It's able to make decisions on its own
Mhm,
to figure out which functions to call, or
mhm.
is this query even complete? What should I go back to the user and ask to make this query complete?
Yeah. So I
I
think
think
chat.
there is no yes or no here.
Uh-huh.
It's like a line. Like you can make it more agentic or less agentic.
Mhm. Okay, so we have our Q&A system or a chatbot, and then, as you said, it has skills. And then once we start adding those skills, like book me a table or reserve me a flight, it becomes agentic. But in order to call it like an agent, then it needs to make its own decisions. And while you were talking about that, I realized that ChatGPT in its current implementation is probably more of an agent because it can do a lot of things, right? So when I can ask it something and then it realizes, okay, this is actually a search query, and I don't necessarily explicitly tell it that you need to make a search. It just realizes, okay, I want to make a search, perform a search, and then it makes a search. Or for example, today I was asking, like I use a tool, Garmin, and it said I need to reduce my BMI. And I said, okay, like BMI is a formula where you have like weight and height. And I said, okay, ChatGPT, I am that tall. How should I weight in order to have this BMI? So first it did some calculation, and then it said, okay, now let me run some Python code. And then it runs Python code, and then it says, okay, your weight needs to be this much if you want to have this BMI. And it did this all by itself. Like I didn't need to ask anything. So this is like, I think it was like 3 steps or something like that. And it just, okay, like the first step finished. Now I need to do the Python thing and then report the results of the Python script, right? So I think, so this is an agent already because it can make its own decisions.
I would say so. The other, like, it can go more complex. Like, you can have so reflection is one of the most important properties of like agentic systems. Like, you have like multiple agents like talking to each other, and like one agent comes back and this is the Python code. The other one like runs it and it's like, no, these are the errors I'm getting. And then this goes back and like fixes that Python code and imports the right libraries and then comes back. So like they can like reflect among each other, because basically like how it all started was like LLMs, they respond to you. And then you have to tell them, okay, this is not correct. It goes back and like comes back with the correct answer. If it can do it itself, like reflect on its output, this is how we write essays, right? We write drafts. We write first draft, we write second draft. But LLMs, they don't have like a backspace button. Like once they start like typing it out, they're like giving you one answer. If we give them an opportunity to reflect and make decisions, that is where we are taking them into the agentic category. Yeah.
Do you know any good resource of, let's say we know now more or less some stuff from what you presented, RAG, and now we want to build a more intelligent system. We want to go to the agent space. Do you know any good resource that we can use for learning about that?
I would say look into the deep learning.ai courses. What they have done is they have collaborated with like different frameworks and tools. One of that is like LangGraph. I think one is Crew.ai. So like these are different frameworks that you can use to build agentic systems. So they like give an overview and then they start building it. Honestly, like personally, I feel like the best way to learn is actually building. So that's a good way to like start.
Okay, fair enough. Thanks a lot. That was a very comprehensive and deep presentation. So thanks a lot for doing that. I took a lot of notes. Some of this the list, so a lot of useful stuff. So thanks a lot for doing that. It was great, and thanks everyone for joining us today too. And I guess that's it for today. So thanks everyone for joining, and thanks a lot for waking up early and making this presentation today.
Thank you so much. Thank you so much for the opportunity.
Yeah. Okay, then see you.